are we up to today? Well, I'm sort of pushing into Tinkerman mix territory a little bit here. I'm doing battery changes. In this case it's a TomTom that belongs to my landlord, so I'm doing a bit of a favour here. But yeah, basically he's been and procured the correct battery apparently, and we'll be opening up this TomTom, which doesn't actually have a model number obviously printed. This is, I can't even tell. Oh, here we go. It's a model QO600, I think, or a model 4FA60. No, I'm not sure what its actual brand name is, but we need to get into this. So, yeah, let's get the screwdrivers out and have a crack. Alright, so the first order of duty is to find the right size Torx bit for these little screws. And I have a tiny selection of little Torx bits here, but whether or not I have one this small will be the question. I think I kind of do here. I know I can usually get a hex bit to mesh with it. I might be staring at the right one right here. Problem is they're so difficult to pick up. I might need pliers to get the driver bit out. And you thought this was going to be an action-packed video. Let's try this one. See if this will do the job. Look here. That one will. Right, let's get the screws out. Right. I assume that when I open the clamshell these two are going to get in the way. And as always I'm going to find a way to pick these up. Where's my magnet tray? Right. Cool. Now let's get the spudger into this. Alright, so the next step here is to get this spudger here and find a convenient way to get between the clamshell that doesn't damage anything. And not having seen or opened one of these before, well, I've seen them, I just haven't opened them. I don't know which way the clips go here, so I have to make a bit of a guess. But I think I'm on the money with that one. I'm going to hold that and I'm going to get another spudger. That's probably a correct name for these things, but I picked that up off Big Clive. He uses that term for these things, and I think that's about right. There's another one. We'll leave that in here and we'll work our way. Well, luckily that didn't pop back in. We'll keep working our way around the edge here until we get in. Right. There we go, there's another one. And another. I'm glad these aren't sharp, or I would have just slashed my finger off right there. It's a technique I know not to use, and I do anyway. It's what happens when you have bad technique with things. You eventually come unstuck. And I think I've just bumped the power button and fired it up. Alright, here we go. We'll get here and we're almost done. Alright, we'll be back once I've got this open. Alright, we've got the two sections open, and we carefully open and inspect for where a ribbon cable might be. And from here, I'm going to pop the retainer off the ribbon cable. If I can get that out from this angle. This is always the tricky bit. I think I might get a thumb in there, might do the job. There we go, and can I just remove that? There's the screen removed. A bit of circuitry on that ribbon too. They're not going for simple. I think that's the LCD controller. Alright, and we're in. Crucially, I don't see a battery anywhere, but I do see a battery cable here disappearing around the corner. Let me have a look here. I'm hoping this connector is the same. It looks very similar. So first order of duty is we're going to flip this cable off using the same spudger so we don't do damage, hopefully. Wriggle it out gently. Right, now we need to take out these small Phillips around here and remove this. In the meantime, while my apprentice trashes the lounge room. So let's get this main board out and see if we can get access to this battery. Okay, so we've got our board in here. So we can lift this up. And my apprentice has decided that I'm filming, so it's a great time to make noise. So I'm sorry if there's a bit of background in here. Up there's another connector here which looks to be a speaker. So we'll need to pull that out. Might use this one. Hold on one moment. Okay, so I've got that speaker connection off and I closed the acoustic regulator in the bedroom, aka the door. Alright, there's our board off. And there's our little battery. Alright, I'm pretty sure this will be stuck down with something. Let's see if we can lift it up. I thought that said Timia for a minute, but it's made in China. Tianyu. I'm not good at Chinese syllables, so I can't tell you exactly what that's meant to sound like. This is very well stuck in. I'm just doing this gently so I don't break the plastic casing. Alright, that's off. Now I probably have some good double-sided tape around somewhere, and this battery looks to be a slightly different size. And always there's alarms and phone calls when you don't want them. Let's get this battery out and we will compare. So, it's the same width and depth, but a slightly shorter battery. And I have the shakes today. This is not treating me favourably at the moment. But it looks like this battery should fit in that hole, and looks to be that the plugs look to be the same. Let's check that our colours are correct as well. Yep, black, yellow, red. Okay, that looks good. Alright, I will find my famous roll of super duper double-sided tape and stick this in, and then we'll put this back together. Alright, so I've got some really good double-sided tape here. This is actually mounting tape from Bunnings that's supposed to be good for something like 30 kilograms to the square centimetre. It's a really strong stuff. So I'm going to, rather than mount it to the battery, I'm going to mount it where we want it, right here, and then sit the battery on top. And this is like a clear goo almost between two sheets of plastic. Now if I can get a grip on here without it sticking on. I need grippy tweezers, that's what I need. Maybe I'll make some of them. Alright, now stick the corner in, position it, and then stick it down on there. Right, that is not going anywhere. I hope this is the right battery. Actually, I've just noticed it's a 3.3 watt hour. This is a 4.07 watt hour, but for a GPS that's plugged in most of the time, that shouldn't be a huge issue. There's a GPS antenna, by the way. That's a module that looks somewhat familiar. It's at a funny angle. I think they've kind of predicted where it might mount. That's my magnetic screw tray that's sticking onto things. I'm hoping magnetizing those back plates is not going to cause a problem. This has a specific way that it needs to go in. It needs to go in bottom first and then top, and then this little cable needs to pull through. There we go. Alright, so now we put in our speaker connector back in with my hand in the way of the camera, because that's about the only convenient way to do this. Alright, now let's hope this goes in as intended. This is our battery connection going in, looking good. The only real safe way is to loop that round the back of that that speaker there. I don't like doing that, but I don't think there's really anywhere else to put that lead. Alright, now we've got to stick the screen on. Oh, we've got to put screws in first. Put the screws in and we'll be back. Alright, so the screws are back in. It's time to reattach this LCD panel. Now I've pushed this little retaining lug forward. I need to get the ribbon cable back in. So this one is broad enough and in a position that I think I can get two fingers on top to push it in, which I like because it's less likely to make a mistake. But now from here, give it a gentle squeeze, starting in the corner, and we work our way around, hopefully not breaking anything in the process. There we go, there's 1, 2, 3, 4, 5, and 6. I think that's how many there were. Now we've got our 2 little Torx tamper-proof screws to put in the bottom, and then find out that we've done something wrong. So it's usually when you find out. It's like when you fix a computer. If you put all the covers back on the computer before you test run it, it's not going to work. Because there's something like Murphy's Law or something like that. Or like, what's the other thing? It's a branch of quantum physics where experiments don't behave the same way when they're observed. I think there was some variant of the double slit experiment that they discovered a similar phenomenon like that, but I may be thinking of the wrong experiment. But nonetheless, quantum physics is interesting. Alright, I don't expect that this battery will be charged, but let's hold a power button in and see if it fires up. Oh, okay, it does. Rather quickly at that. And we'll wait for this to fully boot up, and that's when it should indicate if the battery is flat. And then we'll find an appropriate charging cable for this. Being a TomTom, I expect it'll have a stupid connection, but that does look like a micro B under there. Battery is nearly empty. Alright, let's find a micro B lead. I think I have one over here. Battery empty, going to sleep, it says. Let's plug into my test panel over the back here and see what my viewfinder is, and we'll turn on a supply to that. This is on a 3 amp USB regulator. I expect we'll probably see a charge light or some kind in a moment. I don't see a charge light anywhere. Should this one have one? It's a problem when you do this stuff. You come across these things all the time and you're not quite sure how they should behave. Well, I saw a flat battery indicator there for a minute. Is it charging? Maybe the charge port is stuffed. Oh, no, it woke up when I wriggled the lead. Oh, maybe the charge port's crook. Let's have a look in there. Okay, so there's clearly a charging connection issue. I can't see any junk in the charge port. It could be a dry solder joint. I might have to check that, but in the meantime, I'm going to give it a little contact cleaner, and this is just a plastic safe cleaning solvent. I'm going to give that charge port a little bit of a scrub, and use the long bristles on this. See if there's any junk in there we can clean out. See if this gives it any life. Which way around? That way. Well, that has responded to me plugging it in almost immediately. So that, I think I'll leave this sit for a little while and see if it comes back to life. Okay, so I had this board, or this whole GPS plugged in for quite some time, and there was no sign of any change of charge. So I've decided to put this under the microscope for a minute. So let's get this record started. Okay, so what we're looking at here is the USB port, or the micro USB port. Let's see if I can get it into focus here. Now you'll see it looks like those joins may have dried up a bit and separated, so I'm going to reflow them, but for comparison's sake, let's look at some good connections. And what we might be looking at is just simply the end of the pin in the solder there, but we see they're nice and shiny. These ones here are looking a little bit dull, which means they could have oxidized, or they could have got a bit brittle, and it's lead-free solder, so that is one of the things. I've got this right near the edge of the bench here, so let's drag it near the edge of the bench, and we'll see if we can get the socket in focus here and get a look down the socket itself. Let's have a look here. Are we in focus? Let's come back a bit. see if there's any junk in there. It sounds like my apprentice is in trouble for something in the background. So it looks like this socket is actually fairly clear of junk. I'm not seeing any sort of fluff hiding away in there. So I think we're pretty good. So it could be just dry solder joints. It doesn't look like it's broken. It doesn't look like it's worn out. So yeah, let's get the soldering iron warmed up. Alright, due to a filming error, or a camera error, let's just say, I haven't got footage of this next bit, but let's bring up our microscope footage in the corner here. Now I have applied flux here from this little syringe. I've applied a bit right across the pins. Now I was planning on using this little tiny soldering iron here to touch each pin and reflow it, but because there's some adjacent components we can see down just off the edge of the camera here, I don't really want to run that risk of floating them around the board or bumping them with the soldering iron. So I'm going to use a heat gun. And so let's get this warmed up as we go. It's going to take a little bit to get up the temperature. And I've got a fairly broad tip on it here. So we should be able to see this just remelt all that solder in there. I want to just wait till it sort of flows or gets a little bit molten there and can reform onto the pins without melting that plastic, which I need to be very careful of. Alright. Plus I need to make sure that the flux undergoes a full temperature cycle or it can be corrosive as well. Alright. Just giving that a good bit of heat. I can't see if they've reflowed or not yet, but I'll give that a break. I'm going to warm up the soldering iron as well now, and I might flow a little bit of leaded solder onto there, but let's see. I should have some really fine stuff floating around, but it's MIA right at the second, so I've got some 1mm stuff. Should probably do if I'm careful. Alright, so while this iron warms up, I'm going to turn things off for a second. Let's stop this, and we'll be right back. Alright, we're ready to add some solder. So let's bring our microscope up once more, and let's turn on an extraction fan. And there's a bug or something stuck in there, so it's going to buzz. Now I need to tin this iron a little bit, because it hasn't been used all that much. It's got a bit of oxidization right on the very tip. This is a steel coated tip, so I can't really grind it down at all. So let's firstly I need to prep this solder slightly here. It's got a bit of a hunk and lump on the end. Just going to trim that off. And now we'll go and, this is a flux cord solder too, by the way. Now this is a method I didn't really want to do, because I didn't want to have to risk touching all these other bloody components here. Got a big blob on the back of the connector there, and that was not what we wanted to happen, so we might have to lift that off in a minute. Bit of solder wick to the rescue. Here's some solder wick here. I just don't want that connector getting too hot because of the plastic insert. It's a solder braid here, and we'll just warm that up on the back. Now I'm doing this with naked eye, so I can't see as well as you guys can. And also I've got MS has attacked my optic nerve on my left eye, so eyesight's not as good as it used to be, so if I make a cock up here, just keep that in mind. Go on, solder wick. This iron just doesn't have enough heat to pull that off there. I think though we might be okay, largely because it's not touching any of the contacts under there. Not ideal, but I think I'm going to leave it as that is, and I'm going to see if I can power this board up without that. And while we're here, we'll get some of this circuit board cleaner and clean some of that flux off. And that should make a world of difference to it. I think I need to give it a quick scrub before it evaporates. Give it another dose. This is going to be a simple battery change. That's why people send stuff to me all the freaking time, because it's never simple. Or somebody else has had a crack and decided they don't want to know because it's too hard. Alright, so we've got a big solder blob on the back of our connector here, but these connections look nice and shiny, or sort of. Let's see if I can get an iron in the back of that one and just touch that up a little bit. Yeah, that looks better. And you know what, I'm not going to screw with that. I think it might work. So let's get this loosely reassembled and see if it powers up. Alright, so we have things test assembled at the moment, with no screws involved, and I hope I've got that connector lined up in the right spot there. See if I can actually plug this into it. It might get in there. I hope. We should see a dot if we've got it right. Or some magic smoke. One of the two. Alright, can I fire it up? Alright, so there's still a bit of charge in the battery. We'll see if it decides to go flat at this point. If it does, I might be looking for another socket somewhere. Patience, I guess, is waiting for this. Yeah, battery's going to sleep. Okay, we haven't totally fixed the problem yet. Back to the drawing board. Alright, so we have a plan C. I have an old phone that landed on my front yard some time ago. I think after one of the local, I don't know, maybe they were selling drugs or something. I don't know what they were doing, but they certainly wanted to get rid of this phone. They smashed it on the road, which didn't really work all that well. But crucially, it's got a USB or micro USB port on it that may be of the same type as this one. So I'm going to crack this open and see if I can get some data or get this port off. And what I was thinking in the background there, where I made a little bit of a hiccup, is all the data off this has been recovered and sent to the relevant authorities. So let's crack this phone open and lift this port off here and see if we can swap it over. Alright, so you'll probably have to ignore the wind noise here. Temperature is a problem with multiple sclerosis too. It got a little bit warm and I've had to engage the cooling. That's a neat little connector. So we've got our two boards side by side here, and you'll probably notice that the sockets mount on the board the same way around, and I'm just confirming they are micro Bs. Actually, I'm thinking what's on the bottom of this. No, they're both micro B ports. Okay, so yeah, this could be a little harder to get off here. I have to remove some of this heat shielding, and I like the way they've used these little tactile switches which are on a stick-on membrane. That's a nice idea, but won't matter much to me in a moment, because I'm going to rip all these RF shields off this board and lift that socket off. Alright, so fundamentally they look to be more or less the same connector. So importantly, the orientation is correct and the pins are on the correct side of the board, which means the polarity will be right. So it's time to get the hot air gun out and to lift these off the board. I'll probably change my camera angle to do that too. So let's get set up for that. Now hopefully the light levels aren't too bad here. We're going to stick a little bit more flux on this just to help the release process a little bit. Bit of the gel there, and I might spin this around. How are we going to do this? I think I might use my left hand here to lift this off the board and my right hand to use the heat gun. And it's right now when everybody wants to send me messages. So this is how I like to do this. It helps heat sink the plastic a little bit, and it gives me a bit of mechanical advantage to lift it off the board when it's about right to go. Let's check my temperature for my heat gun and turn on extraction fans, and get these situated in here while the heat gun warms up. Apparently heat gun's at about the right temp, so let's just hit this until it lifts off gently. I'm not putting a lot of force onto this, I'm just holding the position gently, and so when it reaches that critical temperature it should just jump off the board for me. I'm just going to leave this, once it's up to temp, which is about now, I'll leave this just sitting over this whole area for a bit, see if we can melt the hell out of everything. Okay, without the distraction of the camera, I did get it. It turns out there was a fairly vast patch of solder underneath that was holding that whole shield down. Something I don't think is the case with the one on the other board. I think they didn't bother putting a pad under that. But while that cools off, I'll leave that there. It's full of flux now, so I'll need to clean it out anyway. And this board is really hot. But we can see under here where it originally was, there's several pads under there, I think used for strain relief as well. And that board is too hot to hold. I had to get it quite hot. And the fan you hear at the moment is the heat gun cooling off. It goes through a cooling cycle before it shuts down. And a quick little bit of diagnosis. This board, there's a little clock battery way off in the middle over here. And it's been leaking badly, so I think it probably would have had a hard time keeping time, or its memory, and that might have been why it got thrown. So yeah, anyway, I don't really want to harvest any more parts off this. If I was bored, I'd get the right acids and whatnot, and I would get the gold off that. But for now, I'm probably going to replace this bit of blue tack that's very soft now, and I'm going to get the other board out. Alright, now the bit that I'm a little more nervous about. Removing the socket off this board, and we're going to need a bit more flux, I would expect, around here. Try and get a bit of that under the board there. Alright, let's do this. And I'm sorry I don't have a microscope for this, but this big tip melts microscopes. I know that for reasons you should probably not ask. So I'm going to get this nice and warm for a bit, and hopefully at some point I will be able to lift it off the board. For the record, the smell of flux is not a good one. And it's not really good to be breathing it in either, so I'm trying to breathe shallow. This is boring video, I'm sure, watching me just heat things up over time. But it's a little difficult to cut and record and all the other stuff and do this at the same time. I'm only one person. I don't want to disrupt the other components nearby this time, so I've just got to let it get hot and hopefully not melt the GoPro or the desk or anything in the meantime, which I think I am. Yes, I just put my fingers in the heat stream. I need to go apply some first aid, so give me one moment. Okay, so I've had to move everything out of the way a little bit. The GoPro was getting a little warm, the LCD screen on the front was starting to go black, meaning it was getting a little too hot, and so was my desk. It was starting to melt as well. This is just, what's the word for it? It's a laminated chipboard. You can get melamine, and it's a standard size sheet, so I can replace the desk surface fairly easily. So let's get on with this. I tried this method before, having the board on edge. I found gravity worked relatively well to just drop that connector off, and it meant that I could get it happening fairly good up here. I could have it happening fairly closely, and this being the biggest component, was able to overcome the surface tension of the solder. The other components were pulled into place by the surface tension. And this way I can get my fingers well out of the way. We will get there eventually. I think I might do what I did before. I'm going to turn the camera off and I'm going to persevere, and we'll be back when it's time to reseat this. Alright, so we've run into a hitch. I'm going to put two of these sockets under the microscope. We're going to start recording, and we're going to bring it into focus. Where are my tweezers? Over cooling off. So, this is the socket that came off the board, and it's not in a real great state having come off the board, but that's alright. It was buggered anyway. Now notice how many pins this has got. It's only got 5. Now the one that I took off the board now has 7. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 pins. So, not going to fit on the board. But while we're here, I can show you what I've come up with. It's a nice cleaned up the area, we've removed the socket. I can clearly see power and data connections and whatnot like that. So I think what I'm going to do is I'm going to hook up a pigtail to the ground pin right here. Wow, these need a bit of an adjustment. Hook up ground pin here, and I think our positive charge wires here, or this, yeah, this one here is our positive charge, I believe. I've got to look up the specs for the socket first, but I'm going to put a short pigtail on this over to a USB lead, I think, because that's about the only way I'm going to get this to happen. I don't have many of these sockets, and with China being out of action with the coronavirus, I don't think I'm going to get one anytime soon. And I was hoping to have this done within the next hour, so this might be just the compromise that I have to make. So I just rang the owner, my landlord of course, and asked what he wanted to do, and he informs me that normally he charges it through the cradle, which doesn't use the micro B port. So I pretty well don't have to bother about the socket anymore. What I might do though is see if I can connect just a temporary connection up to these pins, see if I can get it to charge. But on the other hand, I might not mess with where I'm at the moment. I might just leave it, give it back to him, and we'll find out soon enough whether or not it charges. So he's already purchased a replacement, so at this point I'm not going to stress too much more about this. I'm just going to reassemble it. I could have saved myself a lot of time, but I guess I'm a sucker for punishment. Alright, let's get this thing back in one piece. Alright, well, it's pretty well time to clean up and pack up now. We have this GPS reassembled, and I've given the screen a bit of a clean. The glass is separating, but that wasn't me. Yeah, we'll see if it works. I can't really test. I don't have one of these cradle connectors here, so we'll find out what happens a bit later on. In the meantime, I need to get rid of some flux and some lead residue off my desk. And I do this after most jobs, and I wash my hands, especially after the last time I went to the doctors and had the curious question to ask of, hey, what do you think my lead count is? Well, he gave me a blood test, didn't he? And yeah, I was on the low level of what one would expect for somebody who is working in a lead manufacturing plant. So that's probably not good. So I have taken steps to reduce my lead intake. And I've got some blisters on the desk now. I might be up for a new desktop. It's like 30 bucks or something. Nothing major. And of course, clean all the major infectious surfaces. This is how you get the coronavirus, or well, any one of the coronavirus variants, because it's basically the common flu that's mutated a bit. So I keep all my desks clean and all my surfaces. You know, your keyboard and your mouse is probably one of the most dirtiest things in your house, and the toilet seat is likely to be one of the cleanest. It's weird how that works. So yeah, we'll leave this all with the end of this video, and I'm sorry we didn't really get to see this actually fully functioning, but I think the battery replacement is fine. Yeah, I'll leave a comment on this video, or I'll change the description when I hear from this owner whether or not it works. So yeah, the battery is of course shipped mostly flat, and this will shut down in a minute. But I didn't completely kill it, it still works. The battery's just empty. So yeah, we'll see you all in the next video. This one might be a bit spotty because of how I've had to edit it, but we'll see how we go. Anyway, see you next time. Right, so I've been in touch with the owner and he gave me the bracket, and then I think I found an answer to the mystery here. You'll notice this bracket has a little chunk cut out of it right next to the socket that's here. So at some point the owner of this had decided that he couldn't put it into the bracket without it interfering with the micro USB socket, which is the one that was damaged and broken, and I had to remove, or I removed it in the process of trying to replace it and failed. But this adapter has a socket on the back, which he did tell me he wondered what these contacts were for. So since then, actually about 2 days has passed since I last filmed a section here, I've been trying to charge it through this port with various connections and leads and all the rest, to no avail. So I think possibly the charging circuit inside this is damaged. I'm going to give it one more shot on camera and see if we can get some life out of it. Alright, so I've got like heaps of these micro USB leads kicking around, but let's plug into this one and see what happens. This is running on a 3 amp output. I'm hoping I can see some sort of red light up in here, but I don't think so. Let's see if we can fire it up. Although last time, as you would have seen on camera, we did this, the battery went home flat and it shut down. I think that's going to be the case here. If it does it again, I'm going to see if I can get some contact cleaner onto these contacts, maybe get some life into it. I said taking longer. There we go. That proved me wrong. Alright, let's get some contact cleaner onto these contacts and see what happens. In fact, we might be able to do this in one cut. Use my contact cleaner here, give it a shake up. Only contacts on one side, and we'll do the same in here. This stuff is plastic safe, by the way. It's something that Electronic Barn, or J-Car, Electronic Barn is my local J-Car store. See if we get any life out of this. Nope. Probably some reflection there. See what, can we see reflection in that? We can slightly. Okay, well, I think this is about all I can do. So I've been to a lot of effort for this, but you know, I'm not asking money for it or anything, so I think that, well, we had some life. I must have bumped the power button. I turned it over. So I try that again. It's certainly not recognizing that it's anything, that there is anything there. I could perhaps solder direct to that socket. The owner here is pretty much resigned to get rid of it if this doesn't work. So we might open it up tomorrow, which will be the next cut in this video. See if I can solder a lead directly to the original micro B socket. But I suspect that the charge circuit's gone. No, I actually think that probably at this point it's a bit counterproductive. So it's been an interesting video, but I don't think I'm going to let this one go. Anyway guys, that's it for the GPS. We'll be back with something else soon. Don't know what. Though there is an Amiga related video coming up soon. Possibly the last one ever. You'll see what that's all about soon enough. Anyway, see you in the next video.